Hello friends, today's topic is relationship between Kp and Kc. We know both Kp and Kc represent the equilibrium constant, one in terms of concentration and Kp in terms of partial pressures. For that, we are considering a general reaction, that's a reaction between A and B. So AA plus BB reversibly gives CC and DD, where capital letters AB represent the reactant and capital letters C and D represent the product. The small letters A, B, C, D represent the stoichiometric coefficients of each reactant and product. Okay, so what we can see, we can write down the equilibrium concentration expression for the same reaction Kp and Kc. Our Kc is equal to molar concentration of C to the power C into molar concentration D to the power D divided by molar concentration of A to the power A into molar concentration of B to the power B. That equation can be taken as equation number 1. Similarly, in terms of partial pressures, you can write down Kp is equal to partial pressure of C to the power C into partial pressure of D to the power D divided by partial pressure of A to the power A into partial pressure of B to the power B. So, we are considering the reaction which is taking place in a gaseous phase. Okay, so we have learned the equation for ideal gases, that is PV is equal to nRT, where P is the pressure, V is the volume, N is the number of moles, R is the universal gas constant, and T is the temperature. Just to rearrange the equation, P is equal to N divided by V into RT, or P is equal to N divided by V into RT, which means that we know the number of moles divided by volume is equal to the concentration. So the equation can be written as P is equal to C into RT, where C is the concentration. So individually, if you are substituting that equation, partial pressure of A will become equal to concentration of A into RT. Similarly, partial pressure of B is equal to concentration of B into RT. Like that, we can write down P, C and PD also. Okay, we are substituting all these equations together in equation number 2, so that the equation becomes Kp is equal to Kc into RT whole raised to C plus D minus A plus B, where small letters A, B, C, D represent the stoichiometric coefficient, or we can write down the C plus D minus A plus B as delta Ng. Delta N stands for the change in numbers of moles and G stands for in gaseous phase. So delta Ng is equal to number of moles of gaseous products minus number of moles of gaseous reactants. If any one of the species are having solids or pure liquid, that cannot be considered as for the calculation of delta Ng. You will be considering only that delta Ng value for only for gases. Okay, and the equation becomes Kp is equal to Kc into RT whole raised to delta Ng. If delta Ng is equal to 0, that means in the left hand side and right hand side, if equal number of gaseous products and reactants are present, or no gases are present in the reaction, we will be taken as delta Ng is equal to 0, and the equation becomes Kp is equal to Kc, because RT raised to whole raised to delta Ng becomes RT raised to 0, which means that 1. So that in that such situation, Kb is taken as Kc. Okay, that's the main point that you will have to understand. For the exam, sometimes they will be giving that they will ask you one question that derive the relationship between Kp and Kc, so that you will have to answer properly. Very simple derivation it is. Okay, Kp, you take the general reaction, write down the expression for both Kp and Kc. Then I take that ideal gas equation, substitute for different gases, and substitute in the main equation, so that you will be getting the equation delta. Using this equation, you will have to do so many numericals. So while doing numericals, you will have to take one more point, that value of R. We know that different values are there for R, universal gas constant. Commonly will be taken if the pressure is in pressure is taken as bar, you will be taking as the value 0.831, or else you will be taking 8.314. Okay, so that you will have to take, and you have to calculate delta Ng. In some reactions that gases will not be present, so that delta Ng is equal to 0. So that you have to keep in mind. Okay, that's the main points that you will have to understand from this derivation part. In the textbook, as well as in the textbook, you can see some in-text question. Along with that one, exercise questions also are given. So in both cases, sometimes they will be giving the value of Kp, sometimes they will be giving the value of Kc. If it is Kc is given, you will have to find out the value of Kc in the reverse order. That if you have Kc is got, you will have to do that expression for the Kc, like that. Okay, so such questions you can expect for the exam. Then the next topic is units of this equilibrium constant Kp and Kc. We know Kc is explained in terms of concentration and Kp in terms of partial pressure. So the unit of the equilibrium constant depends upon the value of delta Ng. Okay, if delta Ng is equal to 0, then there will not be any units for that Kp and Kc. If it is equal to 1, or we can or another values, we will be taking as what delta Ng, depending upon the value of delta Ng, will be taking that units for equilibrium constant. For example, the unit of Kc is taken as mole per liter to the power delta Ng. Okay, if the delta Ng value is equal to 0, then there will not be any unit. Otherwise, the unit will be mole per liter whole raised to delta Ng. Okay, so and similarly the expression or unit for equilibrium constant Kp is taken as ATM, atmospheric pressure to the power delta Ng. Here also, if delta Ng is equal to 0, there will not be any unit for the equilibrium constant. So the equilibrium unit of the equilibrium constant Kp or Kc both depends upon the value of delta Ng. If delta Ng is equal to 0, there will not be any unit for the equilibrium constant. Now we can see some numerical questions. First question is in text question. For the equilibrium equation is given, find the value of Kc. Values of Kc is given, and we calculate the Kp for the same reaction. So what's the equation connecting these two? Kp is equal to Kc into RT all raised to delta Ng. Kc is given already, R we know, temperature is given in the question. Then what we'll have to do? Temperature is given. One more thing, the delta Ng. So how many gas products are there in that right hand side? 2 NO molecules and 1 Cl2 molecule. So 3 molecules of products are there. So 3 minus how many moles of gaseous reactants are present? 2 moles. So 3 minus 2, that is equal to 1. You can substitute in this equation so that you will be getting the final answer. Do by yourself. It is a solved question. Just check your textbook also. Then exercise questions. Question number 7.5. In this one, they have given, they are asking the value of Kc, but the value of Kp is given. The same thing itself. Just rearrange the equation. You have to. The important point is that you'll have to calculate the delta Ng value. If no gases are present, you will have to take delta Ng is equal to 0. Sometimes in the equation only one gas or something like that will be there, so depending upon that number you will have to find out the delta Ng value, so that you will be able to substitute in the equation, so that you will be getting the final answer. That also can be done as a homework. That is exercise question number 7.5 can be done as a homework. If you're having any confusion, you can ask me. You can personally message to me, so that I will be giving that explanation for that. I think there won't be any confusion, because all these questions are direct questions. I will be able to solve it very easily. So in the exercise question 7.5, first one is 2 NaCl reversibly gives 2 NO and Cl2, same equation, but the values are different, so that you can find out the value using that same equation. Then calcium carbonate solid reversibly gives calcium oxide solid plus carbon dioxide gas. Okay, so in this case only one gas is present. Easily, both calcium carbonate and calcium oxides are solid, so that won't be considered in the calculation of delta Ng value. So in the product side only one gas mole is there, so 1 minus 0, so that answer will be delta Ng is equal to 1 itself. So you can directly substitute that one in the chemical equation, so that you will be getting the correct answer. I hope there will not be any confusions or doubts regarding the same. It's very simple calculation they are asking. Such a numerical will be there for your exam also. If sometimes Kc value will be given, you will have to find out Kp, or Kp value will be given. You will have to find out the Kc value. So depending upon that, you will have to solve the question. Okay, as I said, there such numericals will be there. While taking the numerical, depending upon the pressure, you will have to take bar or ATM. Next topic is types of chemical equilibrium. That means depending upon the physical states of the reactants and products, we are classifying that equilibrium into two categories. First one is homogeneous equilibrium and second one is heterogeneous chemical equilibrium. Very simple one. We know what's the meaning of homo, same. Okay, so homogeneous chemical equilibrium means if all the reactants as well as products are in the same physical state, then the equation or then the chemical reaction is said to be in homogeneous equilibrium. What is that? If all the reactants and products must be in the same physical state, then only we can say that the reaction is in homogeneous equilibrium. If any one of the reactant, either reactant or the product are in the different physical states, then it is known as, that is also is in equilibrium, but such equilibrium is known as heterogeneous chemical equilibrium. So these are the two types of chemical equilibrium that we'll have to learn. Two examples you can find out, any two examples you can find out from the textbook. I have given only two simple. So for the exam they'll be asking explain the different types of chemical equilibrium. Two types are there. First one is homogeneous equilibrium. What's the statement for that? If all the reactants and products are in the same physical state, such type of reaction, such type of chemical equilibrium is known as homogeneous equilibrium. If any one of the reactant or any one of the product are in the different physical state, then the chemical equilibrium is said to be in heterogeneous chemical equilibrium. So today's class we have learned three different topics. First one is the relationship between Kp and Kc. Second one is that numericals, using that one including units of equilibrium constant. Then next one is types of chemical equilibrium. Chemical equilibrium, for 1 or 2 marks they used to ask. So with an suitable example, even though they are not mentioning about the example, you are supposed to write down one example for that. Okay, so these are three topics we have covered. So try to see the video, watch the audio and video, and prepare the notes for the before next class. Okay, thank you.